So I wanted to quickly make a video to go over the quiz that you guys took last week. So the first question I think we probably did okay on. Just make sure that it's asking for just what additional information would you need to know, like you don't actually know it now, what would you need to know in order to prove side angle side. So remember, to prove side angle side, the angle has to be between the two sides. So if you look right here, you've got these two sides already. You know that that side is congruent to itself because of the reflexive property. So if you could prove that that angle and that angle were congruent, which is C, I think, ACB, ACD, yeah. So C, if you knew that, then you would have side angle side. For the next one, you're just taking these pieces and filling them into the missing parts in this paragraph proof. If you missed that one, just go back and look at your other options because I think you'll be able to figure it out now. This one I would definitely wanted to look at. So it says determine if you can use angle side angle congruency to prove this. So what you would first want to do is kind of come up with an idea of what you could do in order to prove this. And notice we're wanting to do angle side angle. So I need two angles with a side between them. So if I look at my picture, I see that they're giving us that these two angles are 90 degrees. And since they're 90 degrees, that means that they also have to be equal to each other. It's also giving us that these two sides are congruent. And then you can see this last piece here is that those two angles are actually going to be congruent because of vertical angles. So you can see that you have your angle side angle. So what a lot of people missed on this one is they said that you're given that this angle and this angle are congruent to each other, but you're not actually given that. What you're given is that they are 90 degrees. And since they're 90 degrees, because of, and question 2 is kind of a hint at this, by the right angle congruence theorem, that means they have to be congruent. So since they are right angles, then they are congruent. So number 2 is actually a hint to help you with number 3. So basically, if you did a 2-column proof, you would start by saying that you are given that these are 90 degrees, and then you could say by the right angle congruence theorem, therefore they have to be congruent. Okay, so now you have that those two are congruent. Then you can say that you're given that these two sides right here are congruent. That's given, you're done with that. The next part, you would just have to say that this angle and this angle are congruent by vertical angles theorem. Therefore, now you have enough information to say angle side angle. So a couple things that I noticed that people missed. One of them is labeling their angle measures. So just remember that if you want to talk about this angle A right here, that has to be the inside of whatever you're naming. So for example, you could do B, A, C. Or you could do C, A, B. It doesn't really matter as long as you label it where the A is in the center so you know which one you're talking about. A couple people also called this angle A, which in this case actually is not wrong, but just get in the habit of using 3 letters to label your angles because you'll get confused when you get right here. You can't call this angle C because you don't know which one you're talking about. So you do have to get specific with that one. Another thing is when you're saying that this one is congruent to this one at some point, make sure you read it in the correct order. So your congruency statement, when you say BAC, over here you can't say CDE because of the way that you're reading it. So in the first one, you're reading from the side that's not labeled across the side that has the 2 lines on it. So when you read this one, you need to read side that's not labeled, one that has 2 lines. So you'd have to say angle EDC is how you would say that. Oh, sorry. Yeah, EDC. And then that one's pretty much that. So you could have done 2-column proof, paragraph proof. You could have just kind of written it out, which would almost be a paragraph proof. But what a lot of people missed points on there was the right angle congruence theorem. On the back, people generally did pretty good on number 4. If you missed anything, I think it was this part right here when you said which angles were vertical angles, you listed them in the wrong order. So when you go and start marking through here, you realize that its RPT is congruent to SPQ. So you have to list them in the right order when you write out the angles. Down here, this is where I'd say most of the mistakes were made, and this is a little bit more of a complicated problem. So what I always do when I start to look at how to write a proof, I look at what's given to me and I try to use what's given to me to prove what they're trying to prove. If it's given to you, it's probably given to you for a reason. Another thing is you can't say that something's given to you unless it literally is stated that it is given to you. So for example, over here, there are no markings in this. It's not like little lines drawn on anything. So it's all given in words. First thing is that DE, so this line segment, is a perpendicular bisector of FC. What that means is that it bisects FC, so it cuts FC in half, specifically creating a perpendicular line, which makes 90-degree angles on both sides. A lot of confusion I saw is that they said that people said that this line segment was a bisector of angle D, but it's not. It doesn't say that. So it is only a bisector of whatever it says that it is. So, for example, you can't say that these two angles are congruent. You don't know anything about those two angles. So a couple things that we could say from this is, like I just said, we could say that those two are congruent because of the definition of bisect. We could say that that angle and that angle are both 90 degrees because of the definition of perpendicular, and you can kind of go from there. So the next piece says that DF and DC are congruent. I would say it's kind of my fault here. These should have lines over them, so I didn't count off if anybody didn't put their lines in their proof, but just remember when we're talking about congruence, they should have lines on them, so that would be just a typo on my part, kind of like they do up here. Okay, so that there's not a whole lot to infer, it just gives you information, so that's one we could go ahead and mark in our triangle. Next, I want to look at what we're proving. We're trying to prove that DEF and DEC are congruent. Okay, so if I'm kind of thinking ahead, I see that I've got these two sides, and then I would know something about those two sides being congruent, and then I would know something about this angle being 90 degrees. So immediately I might see, oh, well, 90 degrees, I might think of hypotenuse leg. Okay, well, there's a leg that's congruent, there's a hypotenuse, so you could use that route. What some people did is they saw that these two were congruent, and then they also know that they share this side, so they said side, side, side would work. Let's see if I saw any other ones. I can't think of any right now. But because of the information they give me here, I'm going to use hypotenuse leg to prove it, but it's not necessarily wrong to use side, side, side. I actually think it's a little shorter to use side, side, side. So the first thing that I would do is state what's given. So there's not really anything to do with this first or the second statement here, so I'm just going to go ahead and say it to get it out of the way. So that's given. Nothing to do with it, so moving on, and I'm going to state the next thing. DE is a perpendicular bisector of FC, and that's given. Now what I'm going to state after that is what information that gives me. Well, it gives me a little bit. It gives me that FE and CE are congruent. Make sure you write it in the correct order. FE, so if you can kind of see this looks like it's a reflected triangle, would map over and lay on CE. So you have to write it in the correct order down here. And the reason for that is because of definition of bisect. So a few people said definition of midpoint. You couldn't say that here because you haven't said anything about a midpoint up here. If you said that E was the midpoint of FC because of the definition of bisector, and then you said that those were congruent because of midpoint, that would be okay. But before you say anything about midpoint over here, you had to have said something about midpoint before that. Like explain what does the midpoint have to do with it. But you can jump straight into saying that the definition of bisect is this one right here. That's fine. Then I'm going to go ahead and mark that so I know that I've stated that. All right, the next piece I'm missing is that they are right triangles, like that. So what I could say is that that makes a right angle. So I could say angle DEC and angle DEF are right angles, and that's by the definition of perpendicular. Okay, and then you had a few options here. So you could technically go ahead and say that this is hypotenuse leg because it's a right triangle and it's a hypotenuse and a leg that are congruent, but you would want to get a little bit more specific. So a safer way to do it is to go ahead and say that these two are congruent because they're right angles. So what I would say is that DEC is congruent to DEF, and that's going back to number 2, the right angle congruence theorem. So that one was really just kind of helpful question. Okay, so now you have your hypotenuse, your leg. So the very last statement was to say what you're trying to prove, that DEF, triangle DEF is congruent to triangle DEC by the hypotenuse leg theorem. So again, you could do side, 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 and I think there might have been one more way that other people did, but I was just looking that it made sense, that your steps made sense. Don't include any extra information. So if you, like, I didn't need the fact that DE was congruent to itself, so there's no reason to state that. Only include the parts that you need in your proof. And that's pretty much it. So just use some of those resources I've put in the newsletter and stuff I put on eClass to practice proofs. I will say that it is a little difficult of a concept to kind of figure out and wrap your head around, but basically just create yourself a plan from the beginning about what to do and then go ahead and put it all out in step form.